Hello and Assalamu alaikum. This is Mohammed Kareem from Pak Turk Marif Schools, Clifton Campus, Karachi. So today we will be starting chapter number 5, and the chapter name is vectors, right? So I hope you are all fine and keep yourself very limited and please make sure that you are not going out for unnecessary reasons, because it's time for you to care for yourself and your family and friends, right? So with this message, we are starting today's lesson, which is chapter number 6, and the chapter name is vectors. Okay, I'm sharing my screen now so we can go to that material which we are going to discuss today. Okay, so let me share this screen with you. Right. Okay, so this is chapter number 5. Chapter number 5 is vectors, in which first we will discuss the basic concept, that what is the difference between scalars and vectors. Now we know the physical quantities. Physical quantities are all those quantities that can be measured, and these quantities are divided into two categories: scalar quantities and vector quantities. When we say scalar quantities, so scalar quantities are all those quantities which can completely specified with their magnitude, right? Or and also having an appropriate unit. So these quantities are known as scalar quantities. Scalar quantities do not need any direction to specify them, and they are actually can be added, subtracted, or multiplied or divided by simple arithmetic rules, right? So scalars are just numbers. You can add them, subtract them, divide them, and multiply them with simple mathematical rules. Now, when we say if there are two or more than two scalar quantities measured in the system of units and are equal if they have the same magnitude and sign, right? So this is how you can measure them as well. So let's move on towards some of the example of these quantities. Like scalar quantities may include distance, mass, time, work done, and temperature. There are other quantities also, but we are taking these 5 as an example here. Now, on the other hand, vector quantities are all those quantities which have magnitude, or which require both magnitude and direction with, of course, appropriate unit in order to completely specify or describe itself. For example, we can take an example of force, right? So force can be like we are exerting a force, let's say, of 100 Newton, and it must be exerted in some particular direction. So force have both magnitude plus direction. So that's why we call them vector quantities. Other vector quantities examples can be uh, force, displacement, acceleration, velocity, momentum, right, pressure, and list goes on and on, right? So there are many. So now when we talk about vectors, so vectors cannot be like, unlike scalars, scalar quantities, they can be added, subtracted, or multiplied by the rules of trigonometry and geometry. So vector quantities cannot be added, subtracted, multiplied by the simple rule of algebra. And yes, sign convention is also important, because when you will be, if you have seen, we have when we were doing the numerical problem of chapter number 3, you have seen that when we were taking gravity, so we were also considering the direction as well. So if the body was moving from down, from if a body drops from a cliff, So if it is moving downward, so we were taking this as a positive value of gravity. When if it is going in opposite direction against the gravity, so that was in negative. So all these vector quantities must have direction, and in the numerical problem you also have to be very careful when you are using the values of these vector quantities. Now, if you can see here that vectors can be represented by this arrow. For example, let me write here, for example, we are saying force is a vector quantity, right? So when I'm writing the symbol for force, if you can see here, so I'm also mentioning the arrow, right? It is important for representing the vector quantity, right? So now we will move on towards the next topic. Okay. Okay, let me select this. Right. Okay. So now we will be looking at the addition of the vector by head to tail method, right? Or this is a graphical method through which we will add the two or more than two vectors together. Okay, so if you have any questions, you can ask on the chat box and right now also. Okay, so now we are looking at the vector addition method, graphical method through which we will be using, we will be adding two or more than two vectors together, right? So let me explain you apart from these steps. You can follow these steps also, and you can see this is a diagram also here, which is actually representing the scalar vector addition when we are adding two or more than two vectors. So basically this uh, can be done with the help of this diagram also. And further, basically what we do here in this method, suppose if there are, just like if they are saying there are two vectors here, right? So we can actually connect the head of the first vector. So if you can see here, the head of the first vector, which is vector A, is connected with the tail of the second vector, that is vector B. And then if you can see vector C, it is also connected accordingly. Now this part, if let me show it here with the pencil, this part is known as the head, which is the arrow side here, which is connected with the tail of vector B, and the head of vector B is connected with the tail of the third vector, right? And this is how we will draw the resultant of the vector. And the what is the rule for connecting that resultant vector? That the head of vector, resultant vector, will be connected with the head of the last vector, and the tail of that resultant vector will be connected with the tail of this vector, right? So let's suppose if they are saying here on the board as well, that the situation that they have given us here, that they are saying that if there are two vectors like A and B, so how you will connect them. So let me show it here, how I'm going to connect these two vectors. I'm drawing it right here in front of you. First, let me erase this board, and yeah, here you go. So all this now erased. So now what we can do here, let me see, there is someone else who wants to join the class here. Yes, there's one more student who wants to enter in the class. Okay, so it is also added now to the list. Okay, so right, so let me join these two vectors. Suppose if you are given up with these two vector with the same method as we have seen the diagram just below. Okay, so I am taking this arrow, right? This will help. Okay, so suppose this is vector A. Okay, and let me use a different color. And yeah, this is vector B, right? Or let me connect as the way they are in this diagram, right? So these are two vectors. So you have seen you can see that now I have connected the head of this first vector. Let me use the pencil here again from the board. Yes. So this is vector A. Now it is connected with this vector B, as you can see here in the diagram. Now they are connected according to the same method of head to tail. This is the head of, you can see, vector A, and this is connected with the tail of the second vector. Now again, how to draw the resultant vector? Now resultant vector can be drawn like, let me, I have to use the different color for this. Let me select now, okay, this color. Okay, so now how we are going to draw the resultant, the method is, or the rule says that you have to draw the resultant vector such as that its head is connected with the head of the last vector. Now in this case, the last vector is vector B, so you can say head is connected with the head of this last vector, and tail is connected with the tail of the first vector. So you can also see here the tail is connected with the tail of the first vector, which is vector A, right? So this is what we call it, or we can write it that this is the resultant vector, right? So this is uh, the resultant vector. Okay, so you have seen this, how we have connected the resultant vector, that its tail was connected to the tail of the first vector and the head is connected to the head of the first vector. So this is what head to tail vector tells us about, and this is one way to connect or add them graphically with the help of this diagram. So I hope you have understand this topic also. If you have any queries, so you can write me here on the chat box, right? So we will just answer these queries. Okay, so the next step is resolution of vector, right? So basically what we have to do here, we have to now see how we are going to resolve a vector into its components. So a vector can be resolved into its two or more than two. Maximum you can resolve a vector into its three components, right? What are those three components? X, Y, and Z, right? So a vector can be resolved into its three components. So what is resolution? If we go over onto the definition of resolution of vector, a resolution of vector, it is the process of splitting a vector into various parts or components. This is called resolution of the vector. Now these parts of a vector may act in different direction and are called components of the vector. So we can resolve a vector into number of components, but generally there are three components of a vector, as we are representing here, x, y, and z. So now basically we have to the main part which we have to do cover from this particular chapter, and this will be coming into the exam will be the method of resolving the vector into its rectangular components, right? So now here what we are going to do, we are going to resolve a vector into its two or more, right? So if you can see here, now we have divided this vector v, they have given it a name v. So now this vector have been divided or resolved into its two components. Its horizontal component represented with vx, and vertical components represented by vy, right? So if we can see here, what we have to do here, we have to work out the formula for this vx and vy, right? So basically, if we take this as a triangle, a right angle triangle, so we know that we have three sides of this triangle. This side is known as base, this one is perpendicular, and this side is known as hypotenuse, right? So we will be using here, in order to drive the formulas, uh, the trigonometric identities. Okay, so when we look at the trigonometric identities, we have two formulas like cos theta and sine theta, right? So let me show the derivation here onto the board to you. uh, Let me erase these things from the board first. Okay, okay, so if we can see here, uh, the sides of the triangle. Now if you can see the sides of the triangle, as we have said, this is perpendicular, this is hypotenuse, and this is base, right? So according to the formula of cosine theta, we know that cosine theta will be equals to cosine theta will be equals to base upon hypotenuse. So if we will take the respective sides of the base, so if you can see, base is represented by this Vx. So we will have this Vx here, and hypotenuse is represented by V. So we are putting the value of V. If we rearrange this equation, so it will become Vx will be equals to V cosine theta, right? So this is the formula for horizontal component of uh, the vector, right? So this is the formula for the V. You can take V as a velocity. Velocity is also a vector quantity, right? Similarly, we can do it for the vertical component as well. So if we can see the vertical component here, so let me change this color. Okay, so vertical component can be derived from this formula of sine theta will be equals to, now if you go into the formula, it says now this side will also be same like Vy, right? So sine theta will be equals to perpendicular upon hypotenuse. So if again we'll put the respective values of perpendicular, in place of perpendicular we can put this component Vy, sorry, uh, divided by hypotenuse. In place of hypotenuse we can write h, right? So we have to write its side, which is V. So again we just have to rearrange the formula. So now through this we have found out the formula of Vy, which is the vertical component as well. So Vy is equals to the vertical component of this vector is equals to V times sine theta. Okay, so this is both the formulas, if you can see, for horizontal and vertical components we have worked out. And also in the book or in this handout, they have also represented, or they have also derived through the same manner. In the same manner you can see this, they've also worked out, come up with the same formulas here, right? So I hope you have understood uh, this derivation. As I've told you, this is very important as far as your exams are concerned, right? So let me clear the board quickly here. Okay, so we will just overview today what we have done today in the class so far. At the start we have seen what is the difference between scalar and vector quantities through some examples, right? So then at the start, if you can see, let me recap what we have done in today's class so far. At the start we have seen what is the difference between the scalar and vector quantities with the respective examples, and also the ways how you can add them, subtract them mathematically and graphically, right? Then we have seen this vector head to tail method, and we also saw this diagram how to work out the resultant vector, right? And now right at the end, last but not least, that we have seen that how to resolve a vector into its respective components. So we have seen today that in our course we have to resolve them into its rectangular components, which is Vx and Vy, and we have seen, and we have seen on the board here also that I have showed how to work out these formulas. So I hope now this is pretty much clear to you, and that was it from the class today. We will see you on the other side, and we will come up with the numericals in the next part. See you then. Allah Hafiz.